Thanks for the privilege and welcome to our next class as we continue with our quadratic equations. In our first class, we have treated a method of solution by factorization. Here in this class, we're going to treat that of completing the square method. First of all, quadratic equations. Quadratic equations. We're going to use a method by solution by completing the square method. The square. Completing the square. Solution by completing the square. Now, in our previous class, we've been told that when you are given quadratic equation that we can seek solution of this quadratic equation using different means. Now, here in this one, and we were also told that there are some that you may not really factorize. There are some that we may not really factorize. There are some that we may not really factorize. Example of such is this. Square minus 6x minus 4 all equal to 0. Now, if we ask to solve this using factorization method, we will see that it's so tedious, we're going to spend so much time, and if possible, we may not even factorize it. Now, that is why we have different methods, other methods of solving quadratic equation. Now, here in completing the square method, what do? When we have an equation of this form, assuming that a here is greater than 1, assuming that a is greater than 1, what we do is to divide this entire equation by a. So we're going to have this plus b over a x plus c over a all equal to 0. This is what we're going to do. Then before we continue by taking this constant term across the equal sign, then we're going to have something like this, b all over a x plus equal c all over a, c all over a. This is what we're going to have. Then next, what we're going to do is to add to both sides of these equations the square of half the coefficient of x. The square of half, like half of this one, then we square it, add it to both sides. That is what we're going to do. Now, we are going to illustrate by using this example that is before us. First of all, let's confirm if the discriminant is a perfect square. Here we have x squared minus 6x minus 4 all equal to 0. Now let's see if the discriminant is a perfect square. For us to do that, we said is b squared minus 4ac. Now our b is negative 6 all squared minus 4, a is 1, and our c is minus 4. Now let's check if the discriminant is a perfect square. Here we are going to have 36, then this to this will give us positive, then this times this is 4 times this is 16 plus 16. When you bring this together, we have 2 here, this plus this, then we 12, we carry 1 to here, it's 2, then from here 5. So you can now see that 52 is not a perfect square. 52 is not a perfect square. And it's merely looking at this, you can see that what is that number that when you multiply it will give us this and this, that is negative 4x squared. And this, so those same numbers, when they add, it will give us. You see that we will spend so much time and we may not even find it. So we say that these things cannot be factorized. It cannot be factorized. So we are going to employ the method of completing the square. We are going to employ the method of completing the square in solving it. It's still quadratic equation. Even if we can factorize it, it's still quadratic equation. So we must look for solution, the solution set of this quadratic equation. So as I illustrated in the first case, here the a here is 1. So we don't, have anything to divide through. So all that we need to do is just to take this constant term across the equal sign, then we are going to have negative 6 all x all equals. So this is negative 4. Going to the other side, it becomes 4. That is what we are going to have. Then next I said we should add. Let me add, because this thing is very, I want everybody to take note. This is very trickish. Most people get confused at this point. Add to both sides of the equation, both sides, the square of half the coefficient of x. Add to both sides the square of half the coefficient of x. And what is the coefficient of x here? The coefficient of x there is negative 6. So half of it will be negative 3. Half of it will be negative 3. And we said we should square it. So what we are going to add here is negative 3. Then we square it. That is what we want to add to both sides. So in doing so, we are going to have x squared minus 6x. Then we add negative 3, which is half of the coefficient of x here. Then we square it to both sides is equal to, this is 4. We are adding it to both sides. We are adding it to both sides. This we have done. Now after this one, what do? You just simplify it, resolve it. When you resolve this one will give us x squared minus 6x plus, because this one times in itself, this negative sign becomes positive, and you're going to have 9, which you have 4 plus 9 as well. Here we are going to have 13. This is what we have, 13. 13x squared minus 6x plus 9 equals 13. That is what we have. Now from here, if you look at the left-hand side of the equation, you can see that we can factorize that. Now I will just factorize this very one, but after which I will not again, because I have other simpler method of just approaching this kind of problem. Now look at it as it is here now. If you look at this, you will see that the discriminant of this, if you check it, it will be a perfect square. So what we do here now is two terms that when you multiply, it will give us this, and those same terms when you add, it will give us. And those terms are just 3x, negative 3x, and negative 3x. When you add them, it will give us negative 6x. When you multiply them, it will give us the positive 9x squared. That is what we are going to have. So that is, we are going to have x squared minus 6x. Sorry, in place of this minus 6x, that's what we are writing. Negative 3x plus 9 all equal to 13. That is what we are having. So from here, we just factorize it. X, as we did in the first case, x, negative 3. When you open this bracket, you get this stuff. And we said what we are going to have here will be the same thing here. So this, we are going to x minus 3. What is it that we are going to write here so that we will have this is negative 3. When you multiply this, you get this. When you multiply this, you get this. All equal to 13. That is what you're going to have. Now from here, in our previous class, we have said just take these terms that are outside where you have this minus 3 into take one of these terms in the bracket, which is also this, equal to 13. You can see that the terms that we have inside here. Now I want us to note this very carefully. Now the terms that we have inside here, they are the same. So irrespective of the problem, by the time you get to this point, you will see that the terms that we will be having will be the same. So this you can also simplify as this over 3 raised to power 2 squared, all equal to 13. Now our interest is to, there is an unknown here, so to make this unknown the subject of the formula. So what do? We square root both sides. When we do that, we're going to have this 13 equal to the square root of 13. Plus or minus the square root of 13. Now take this to the other side of the borderline, then we're going to have this. This becomes positive 3 plus or minus 13. So our answer is x is either equal to 3 plus 13 or x is equal to 3 minus 13. So these are the solution set. So you can now see that in this one, completing the square method is also straightforward and is as simple as ABC. First of all, what we did was taking the constant to the other side because a here is just 1. After then, we took the square of the half of the coefficient of x and we add it to both sides, and after that we simplify. Now, there is something that I want us to note here in this point. I said, if you look at this, reaching this point, there are times that assuming the coefficient here is known, and when you divide it, assuming like we have 5 here now, some persons may struggle in getting the stuff factorized. So what do? Simply that thing that you have added, just take it, add x to the variable to it, and just square it. It will give you the answer. Now in our next one, we are going to consider that, and you will see how everything will look like. And I believe it will work out very perfectly. Let's consider another example. Another example where we have, let's say, 2x squared plus 10x, 2x squared plus 10x minus 7 is equal to 0. Now, if you check this, you will see that we may not also succeed in getting the discriminants. So what do? We use the method of either the formula method or completing the square. For the sake of this class, we are using completing the square method. So what do? We said, if this one is greater than 1, divide everything through by the coefficient of x squared. So if in doing that, we're going to have, if we divide everything by the coefficient of x squared, this one will go off, and we are going to have 10x all over 2 minus 7x over 2 is equal to 0. Now this one you can simplify it further, and you have this plus 5x minus 7 all over 2 equal to 0. Now reaching this point, we said take the constant term to the other side of the equation. Now in doing so, we have this plus 5x, taking it becomes positive, equal to 7 all over 2. That's what we have. Now once you do that, the next one is to add to both sides the square of half the coefficient of x. Now the coefficient of x here is 5. So we are going to take half of it, then square it and add it to both sides. So what do? We say x squared plus 5x add it will be 5 all over 2 all squared. Some persons may want to write it as 2.5. It's still the same thing, but for the sake of this class, I will want to keep it like this. And we add it to both sides. And here we have 5 all over 2 all squared. That is half of this one, that is this. Then we say we square it. That's what we have done. Now, we can now simplify these things further as we continue. We can simplify this thing further. Here, you can write x squared plus 5x. Now, if you open the bracket, this one is affecting all of them. We have 25 all over 4. If you square this, this is what you're going to have. All over 7 all over 2 plus 25 as well, all over 4. Now, this side of this thing, we have 2 fractions. So you can consider the LCM, which is 4. The LCM is 4. Then 4 divided by 2 will give us 2 times this will give us 14. Plus 4 divided by 4, 1 times this will give us 25. So if you resolve this, you are going to have 39 all over 4. Now in this place, we are still having x squared plus 5x plus 25 all over 4. Now we have gotten to the other case where we try to look for 2 terms that we will factorize. Now I said don't bother looking for those terms. All that you need to do is just to take those terms that you added to both sides, and that is this thing that we have. So what do I do? So that you won't waste your time. This is what we do. This is what I added to both sides. So I just add x to it. It's positive here. So you say positive 5 over this, all squared. Now, if you open this thing, you are going to get this thing back. So this is more of like having 2 of it as we got in this case. Because I said what you have, you are going to have it in 2. So it's the same thing. Now, if you open this bracket, you will arrive at this answer. but we are going to check if what I have done is true. Now let's try to open this bracket to see if we are going to arrive at this answer. We have x plus 5 all over 2 into x plus 5 all over 2. This times this will give us x squared. This times this will give us plus 5x all over 2. Plus this times this will give us plus 5x all over 2. This times this will give us plus 25 all over 4. Now, if you simplify this place, if you collect these terms, you are going, the LCMs are the same, so you say the bases are the same. So you say x squared plus this gives you this plus this gives you you've got the alike terms. It gives you 10x all over 2 plus 25 all over 4. Now, if you simplify this further, you are going to have x squared plus 5x plus 25 all over 4. So you can see that it's still the same thing. So I said, irrespective of the number, once you get to this point, all that you need to do is just take that stuff that you use in adding to both sides, then add a variable at the front, then square it. That is what you're going to have. Irrespective of the case, that's what you're going to do. So from here now, all that we need to do is just to go ahead, simplifying further. Just to go ahead, simplifying further. This we can do by, from here you can see that we just have one unknown here, so it's to make this one the subject of the formula. So first of all, we square root both sides. In doing so, we are going to have x plus 5 all over 2 is equal to the square root of both sides. If we square root this, we're going to have 39. If we square root this, we are going to have 2. That's what we are going to do. Now take this to the other side of the borderline. So we have x is equal to, this one crossing becomes negative 5 all over 2 plus or minus 39 all over 2. So you can see that we have 2 here, we have 2 here. So the LCM is the same. So you can just have the denominator at just one thing. So we have negative 5 plus or minus the square root of 39 all everything over 2. So our answer, the root of that equation is x is either equal to negative 5 plus the square root of 39 all over 2, or you say x is equal to negative 5, negative 39, everything over 2. So you can now see that completing the square method is also very simple, and it is good to go. If I were you, I even prefer this method. If method of solution is not really specified, this is what I will really want to use. This is what I will really want to use. Now, let's consider other cases. Of which the audience, you're going to also try some for yourself so that you enjoy life. You now confirm that life is reasonable with mathematics. Life is reasonable with mathematics. Now let's consider these ones. Let's consider, say, 4x squared minus 16x plus 3 equal to 0. One case. Then second case, let's consider 3x squared minus 4x minus 2 equals 0. Then C, third case, let's say 5x squared plus 10x plus 2 equals 0. Now, I'm going to solve this one. Then the audience, please try as much as you can to solve that so that you can refresh your memory with that. Now, we are going to solve this. Now, what we have here is 4x squared minus 16x plus 3 equal to 0. Now, completing the square method, what do we do? First of all, there is the a here is greater than 1, so we divide everything through by a first. So in doing so, we are going to have x squared minus 16x all over 4 plus 3 all over 4 equal to 0. That's what we have. Now, but this we can also simplify. So we are, if 16 divided by 4 is negative 4x. Now this one, you take it to the other side, so it becomes negative 3 over 4. Now reaching this point, what do we say? We said we have to take the square of half the coefficient of this. So the half of this one is negative 2, then squaring it, add it to both sides. So what we are going to have is this, negative 4x, Then add the square of this, half of it, half it will be negative 2 all square. Add it to both sides, this is it. Then equal to negative 3 all over 4 plus negative 2 all square. Add it to both sides. Now you can further simplify this. We can further simplify this by saying x squared minus 4x. Now if you multiply this, you're going to have positive 4. Negative 2 times negative 2 positive 4 equal to 3 over 4. This one also gives us positive 4. Positive 4. Now here is more of like positive 4 over 1, which is still the same thing as 4. Now you take the LCM. If you take the LCM, this one becomes 14. The LCM here is 4. So 4 divided by 4 will give us 1 times this will give us 3. Plus 4 divided by 1, 4 times this will give us 16. So here we are going to have, here we have negative sign. Negative sign is there. Negative sign is there. So here we have negative sign in front of this 3. So if you simplify this, you're going to have positive 13 all over 4 at this other right hand side. Now this other side we have x squared minus 4x plus 4. Here is pretty simple. You can factorize this, but we are not going to factorize it as I treated earlier. I said those things that term that you use in adding to both sides, just take it. The variable here is x, and what we added was negative 2. So I said just square it, and if you open this bracket, you are going to have this. You can check it yourself. If you open this bracket, you are going to have this pretty term equal to, this is what we have, 13 all over 4. 13 all over 4. Our interest is to make this the subject of the formula here now. So we square root both sides so that this one can go off, and we have 2 all over the square root of 13 plus or minus. This one will give us 2. That one will give us 2. Now this one coming to this other side, it becomes positive. So we are going to have x will be equal to positive 2 plus or minus the square root of 13 all over 2. Now this one is also okay. You can leave it like that, or you can also tidy it further by writing x is equal to, taking the LCM, which is 2 to here, we will make it 4 plus or minus the square root of 13, everything over 2. So our x is equal to 4 plus 13 over 2, or let me write it. Our x therefore is equal to 4 plus the square root of 13 over 2, or x is equal to 4 negative square root of 13 all over 2. So you can see that completing the square method is also very simple. Now these other two, I want the audience, the class, to please try use them to refresh your memory as we continue with our next class, as we treat a method of solution by the formula method. Please, in every of our class, try as much as you can to, those of you that have not subscribed, try to click on the subscription button so that you can always have notification. It doesn't cost you anything. It won't cost you anything. Just click on the subscription button so that you can get notification always. Thank you, as we look forward to having the other class with a solution by the formula method. Thank you.